Okay, I think we'll get started. I think we'll have everybody here who's interested in joining to learn about CBRAIN. We're going to use this in the context of the BigBrain data, but as I hope you'll find out from what you're seeing here today and doing hands-on, and from the opening parts, that it's more than just BigBrain data. BigBrain is just one, I would say, the data spaces, the data types that people can work with on the platform, and hopefully you can see some of the generalizability to your individual areas of work. So my name is Bryan Caron, the Director of Operations and Development of the platform that's called NeuroHub, and the technical lead for the CBRAIN development team at McGill. So today we're going to go through two parts. Just going to give you an overview, quick introduction, a little bit more detail than what I did in the little pitch session to give you an idea of what CBRAIN is and what it's capable of doing, and then we'll get your hands on with some basic exercises, but just to give you, like I said, a flavor of what there is, so then you can then continue your investigations into using the platform for your work, whether it's BigBrain data oriented as to the reason why you're here for the next few days, but then also connecting with other different data types and other elements of data spaces and compute resources. So as I was mentioning during the tutorial or the pitch session, there's all kinds of different data modalities that people can work with. So if you're working with the, say, imaging side, particularly on the MRI, you're going to want to be working with data such that you're not just doing it in a way that you're doing it once, you're going to be working with it many times. You want to make sure, though, that you're doing it at scale. So at some point, you're going to start small, but then you want to grow big and work with more data. You want to make sure, though, that not only from a tool point of view that you're understanding what that tool is, but you also want to make sure that all your workflows are reproducible so that you can come back later. You're not relying on something. You say, well, how did I build this application, compile it? If you come back or a student comes back several months later, all that information is lost, right? So you want to do that reproducibility. And you're obviously going to be looking to collaborate with your colleagues, whether it's in your lab, working with your colleagues at other institutions. You want to be able to share those data elements. You want to be able to also share the applications and also the parameters that you ran those applications on the data. So how do you do that? And you're given a choice, as I was mentioning in the pitch. Typically when you're using high-performance computing or cloud-based resources, you're going to be doing things on the command line. As I said, learning to compile, download the packages, download the data, organize it. You're going to be creating a structure, all kinds of details that you can say, well, do you really want to be focusing on that, or do you want to focus on, I would say, more the scientific elements of what you're trying to compute? And that's where CBRAIN comes in, particularly where we try and simplify the view by removing the complexities of the command line. Okay, we want to move you or your users to, I would say, a more web-oriented application space where you can then, instead of working on that command line with the nitty-gritty details, have a web-based system so that you can make those connections between your input data, the tool, and your output, such that you can do an easy way transitioning, as I said, from that command line environment to something that's web-based, while still achieving the goals of scaling up your science, collaborating with your colleagues, whether it's local or elsewhere on the world, and then be able to scale up the analysis to different data sets, whether it's the MRI imaging, for example. Again, the MRI imaging can be not exclusively, even though our origins are, of course, with the name like CBRAIN, it's more neuro-oriented, but we're now doing it in the application spaces of things like cardiac imaging is an example done here. That's for one of the projects that we're applying CBRAIN for the analytics to. You can also do it to single-cell transcriptomics. Again, CBRAIN really is agnostic to the data space because we're working on more in the orchestration of the workflows. And the same thing with EEG data, for example. So you'll see some coming up in a few moments, I would say the tool space that we currently make available and that's continuing to grow right now. So the elements that, as the end user of CBRAIN, you come in through a web-based portal, right? Okay, and then you're going to say, well, I want to access data, whether it's data that I bring myself or yourself to the table, but you're also going to be wanting to not duplicate things, right? Why upload data or download data from a repository and then upload it into a system for analysis again? You're making unnecessary copies. They're both costly as well as, from a dollars and cents point of view, but are also costly from a resource and environmental point of view. So that's why we tie into many repositories, whether it's ones that are commonly connected to things like you'll heard in the other session coming up about DataLad, We have data lab connectors within CBRAIN. A lot of our other repositories that you heard about in the opening from Alan, UK Biobank, of course, UK Biobank is a little different because it's not, for example, an open data set. You have to have permission to access it. But for all our McGill-based researchers and their immediate collaborators, that access to that data set is there. Same thing we have other Canadian Open Neuroscience Platform. All the open neuro data sets, if you're working with those, are accessible through the same back end of DataLab into our environment. And then we also have ones in the US, HBCD, ABCD, as well as now we're just finishing up some modifications that will allow all the eBrain's DataLab-based connections into CBRAIN as well. So if you're working with any of the data that's sitting in eBrains that you'll heard about in another session concurrently with this one, those will be accessible as well to your analytics pipelines within CBRAIN. And the nice thing about this environment as well, yes, there's the web UI that I mentioned, but if you're doing things more programmatically, all those data accesses, so anything you do on the command line, or pardon me, all the web UI, you can do also programmatically through the Jupyter Notebooks, and I'll touch upon that in a moment. And we also have so this is one part of an overall ecosystem that ties into also data collection and management, something in my partner's space called Loris. We're organizing and collecting multimodal data, whether it's epigenetics, phenotypic information, biospecimen. If they link together, they're not together as packages. You can take different components as you need, but it's part of the overall ecosystem that we have. So what you're going to see and get particular examples, hands-on exercise of working is, so rather than working with files in command line, you're going to see your data spaces in the web view. And the data view doesn't just look at one data space in terms of where it's sitting on one system. You can actually have data across a federated network of locations, and you can work and see them all together and organize them not just by location, but you can also organize them by project. So if you have different data files at different resident space locations, you can organize them by projects, even though they might be distributed around the world. And you may also have specific reasons why that data can't move from those locations. You can still work with that in CBRAIN. You can also take advantage of what's in CBRAIN. We have a built-in visualization tool, so for things like Nifty files, Mink files, directly within the browser, you don't have to download it to your local system, open up a local viewer. That's all directly viewable within CBRAIN. And then you'll also get some hands-on pieces with the processing parts. So once you've identified your files, on the bottom, and again, I'll go through these with you in an exercise momentarily, where you identify the files you want to work with, then you select them with a checkbox, you then select launch, and then you get a menu of all the tools that are available to run. And again, you can search through tools either by name, you can search through them by category, so there's different ways of finding them, and you can discover those in the platform. And this gives a high-level overview of the categories, again, focusing predominantly on the neuroimaging side that are in the platform. There's over 160 tools now. Everything here is containerized. Is there anybody here who doesn't know what a container is? So everybody knows what a container is? Perfect. So a container is just really everything is built into one logical structure so that you can actually then move that application around in a very portable way, right? The beauty of that is it also makes it very easy for things to be reproducible. And together with one of our partner projects called Boutiques, we're able to transform what that container can do into a web-based UI so that all the input values that you set, all the parameters that you set, all the output destinations that you want to specify, they're all contained in something called a Boutiques descriptor, which is just a JSON file. But from a web point of view, it just gives you that easy-to-use selection of menus to control how you want to run that tool on particular data sets. And then CBRAIN does the orchestration part. Okay. The link that's on the screen here, and all the slides here are available on the agenda page. For this one particularly here, it'll bring you to a link. You don't need an account even to access the link here. It just shows you all the available tools and data sets, and there are different modes, I would say, access. Some of them are open to the world. Some of them are restricted access for the nature of the data, but that gives you a representation of the current sets of tools and data sets that are available. And if you want to get into more detail, I won't enumerate all these. There's too many on the screen and too many more on the list. But you can see it covers the full spectrum if you're looking at things like, that are more structural in nature, structural MRI analysis, all the way through PET analysis, tractography, all the way through. And then, as Alan was saying, we're adding more and more tools, particularly in the genomic side, single-cell transcriptomics. But really, with the nature of it being container-based, as I said, CBRAIN is really agnostic to the science. So just as a concrete, I would say, benefit of this, even if you're not working in the space of single-cell transcriptomics, but this example really quantifies, I would say, the ease of and use and benefit that it brings. So on the bottom left here, you'll see just an input set of data. It doesn't really matter what it is in this case. In this case, it's an input of set of FASTQ files for the single-cell application. But the nice thing is on the CBRAIN side is that you work with the data files, you identify the ones you want. You work with, again, taking the fact that the boutique side is transformed all the necessary inputs into that web-based format that we use in CBRAIN. So you make sure you then, from a drop-down menu, specify the input files, any particular parameters you want to set. And then from that, the pipeline runs. And again, this can be on a set of resources that are connected across all the different systems in CBRAIN's connectivity space. It could also be ones that you have access to. It could be a variety of them. And then you visualize the output depending on the nature of the pipeline. It might output be then visible directly within the browser. So in this case, the output normally would generate in this particular application an HTML file with some visualization of the results. Because of the various formats that we support in CBRAIN, this is directly all, again, viewable in your browser. You don't have to download it to your local computer, visualize it there, and then go back and forth. Everything is directly workable within your web browser. And naturally, the benefit of this is all of this information is recorded. So the part where you work with your input data, what the actual parameters that were set, the container that was used, including the version of that particular containerized tool, and the output data, all that relationship from front to end is recorded in the CBRAIN side. So this is just a more concrete example. Well, maybe I'll skip through some of this just to save some time, but just gives you a visual representation. Like I said, everything parameter-wise that you would set inside a tool is either through a drop-down menu. That way, you don't have to worry about mistyping some parameters if you're working on the command line. Some, depending on how the application tool is written, it might have required 2 dashes before specifying a parameter, but you might have written 1. You don't have to write complex bash scripts, other shell scripts, and then worry about trying to organize and save the output data and building that relationship between input data, tool, and output, right? It's all recorded directly within the system. So what you end up getting in the end is a way of seeing then directly the status of that job as it runs. So you can look at your full log history and say, okay, I ran tasks for this particular tool, this version. I ran it on a particular system that's connected to the CBRAIN. I see the status. And sometimes jobs fail for various reasons. It might be that the resource that you submitted it to had a power outage right in the middle of the application. Then you might see the failed condition. Others you can see completed. Then you can actually then drill down into the outputs, and then you get more detailed information that otherwise you would have to log and store in text files. Then you're trying to mine them and you're trying to figure them out. It's a lot easier, when it was produced, when it was created, when it was last modified, where it was stored, what the output size is. So all these things are, not ephemeral. They're purposely stored long-term, so they have that information at ease of use. And then you can then visually, as I said, navigate the output, whether it's a hierarchy of files. Again, it depends on the nature of the tool. It's, again, visible there. You can extract certain individual files if you want. You can then, depending on the nature of the file produced, directly, again, view it within the browser. So that's, I would say, the web view side. So, of course, depending on how you're doing things as well, you may also then be doing some of your post-processing via notebooks, for example. And the API side that we have within CBRAIN facilitates that. So you might doing your first stage processing, I'm going to say something with like FreeSurfer or something like that. You'll run the pipeline through FreeSurfer, through CBRAIN, and then you want to run notebook analysis on some of the outputs. You can do everything that we've seen visually within the web UI through the API side. So you can log in, you can then work with tools, you can submit tasks, again, from our inventory, but you can also handle data. So in particular example that we have detailed on our GitHub page, a particular example, we ran some nailearn analysis on some of the output files that were produced. So these files were imported directly from CBRAIN, taken as input, run the application on a Jupyter Notebook instance, and then we can visualize the output working with it there. And all these outputs that get produced, whether of course, your plots, you can then upload things back into CBRAIN for sharing with your colleagues as well. So there's a lot of flexibility in terms of what you can do with it, going from, as I said, a pure web-based environment all the way through to connecting it to more, let's say, the downstream analyses. Again, the link there, which you can have access to, like I said, and the agenda provides some pointers to some examples. In terms of connected resources, so just don't think of CBRAIN as maybe just as a black box, but that black box, though, is connected to distributed sets of data and distributed sets of compute resource. And the good thing about this is that we provide a general purpose set of access as part of our allocation on the Canadian-based infrastructure called the Alliance. So that's for, I would say, more general purpose, smaller community use. But if you have specific allocations, if you're coming from a particular institution, say our colleagues here in Germany at Jülich and JSC system, that's tied into CBRAIN as well. So if you have a project that's, you're allowed to use those HPC resources and you want to run CBRAIN on that, you can actually then run your application on that environment. And then we connect to other supercomputing systems. Some of them are more specific to individual projects. All that's a fine-tunable parameter within CBRAIN. So we have some projects where the use of the resource is exclusive for certain projects. But as I said, the more general purpose one is based on our Alliance allocation, and ones that are specific to things, some of the BigBrain work that we're doing together with our colleagues is based on the resources under Jülich's allocation, specifically on the JSC side. So, but this just gives you an example of the scope of the resources that are connected. And then, as was mentioned, we have about over 2,000 users. That's not all active at the same time, right? So on a given annualized period, we're talking about 400 users on an annualized basis coming and going. And the nice thing is that people can come in, work with their files, and of course they will need to come back. They'll review things. They will rerun some of their analyses, but they'll rerun it, say, with a newer version of the tools that have come out. All that ability is there within the overall framework. And the last part I just want to mention, as I said, highlighted it during the pitch part, is the connected data spaces. So the advantage here is, as I said, you don't have to do all that separate download and management. We have different repositories connected, such as the biobank in our case at McGill, but anything that we use from the BigBrain side as part of HIBALL. Other ones, we have other open repositories based on our infrastructure, Canadian Open Neuroscience Platform in Canada. Other repositories also including Open Neuro, as I said, if you go to Open Neuro, we have a view on CBRAIN button for every single data set that's there. You can then work with that data set directly within CBRAIN for analysis as well, and that's leveraging the data lab connector there. And the one on the left is just an example from the Canadian Open Neuroscience Platform, which anybody can go to and access. It's not exclusively for Canadian use, it's open to the world. And like I said, we're just finishing up some work now that will leverage the data lab part that connects into eBrains. And as part of that, this is really just the two pillar components. CBRAIN is, whoops, wrong button. CBRAIN is one of the main killer components of the NeuroHub infrastructure. This is one of the neuroinformatics infrastructures coming out of the Healthy Brains, Healthy Lives initiative at McGill. So we try and bring together all those elements that interconnect the management side of the data, but also the processing, and then, of course, finally the sharing, as well as the exploration from notebooks. Certainly, the collaborators and the people who are working on the project, and without them, what you see today with CBRAIN and the connected pieces wouldn't be possible. So that's the introductory bit. Right on time, almost. Any general questions before we get into the hands-on part? Okay, I can tell everyone it's morning, so hopefully we can get them through this smoothly. So what we're going to do is do some exercises now. Like I said, we're going to use the BigBrain as an example data set that'll teach you a few things just to get familiar with CBRAIN, okay? So we'll do about ideally, if we can make it through 4 of these, we're doing good, right? And they're not challenging, but we'll just go through the process of just getting connected and navigating to actually see and interactively work with some of the BigBrain data sets pieces. And you're going to run a tool called BigBrain Warp. This is one tool that works on some of the BigBrain data coming from some of my colleagues elsewhere at McGill. I'm not a scientist from the neuro side of things. I'm more on the informatics pieces. But what we're going to go through is the process of learning how to apply a specific tool to some individual data, just starting with one file. But what you'll see as we go through the later exercises, what you've done for one file applies to any number of files that you may want to work with. And you don't really have to change very much what you're doing to scale up from one input file to thousands even if you want. And then you'll be able to take a look through exploring some results and occasionally a couple other exercises that you can do in your own time depending on how fast we move through things, okay? So first step, getting people set up. I know some of you may have gone ahead and followed the instructions and getting set up with an account ahead of time, but for ease of purpose, I recommend we go through one of the environments that we just stood up, just the separate accounts for the particular workshop today, okay? So we're going to be using ones that are just called, identified based upon an individual sign-up. So if everyone goes to this particular web URL, okay, and then you'll get access to a sign-up page that will let you just specify your email, and then you just have to put in your input email, and that's all you need to do. Just tell us who you are, right? I'll give you a moment to type in that URL. Maybe once you've done that, just raise your hand and let me know, and then we'll go along at a pace that works for everybody. And these accounts that you'll be using are just temporary for today, right? But then there's a sign-up page on the platform entry login page that if you want a more permanent account, then you can sign up for that. But it'd be best if you can use just the workshop ones here for today. Has everybody filled it out? Maybe just a show of hands if you've gone through. 2 in the back, 3, 4, 5, good. Okay, so with that address, you just need like I said, your email. And what you're going to do is it'll be telling you exactly which one of the accounts you'll be receiving. Whether it's the HB, just for the HIBALL, and you'll be getting some 2-digit numeral afterwards for your account. It won't be sending you any emails, just that you have to remember the account that you were given. And then the ease, just to make it easier, your account password will be set to your email address, okay? So is there anybody who's having difficulty in getting through to get the account creation part? If you do have issues, raise your hand. Okay, I don't see anybody. So then once you have that, so that's just the creation part for the purpose of the workshop, then you're going to go to the main portal page. So it's everything that you typed in prior, but just take away the workshop extension, so just portal.cbrain.mcgill.ca. Okay? And from there you can log in with, again, the account name that you were given. So HB, which one it was assigned. And then your password, as I said, which is just your email. Is there anybody not able to get in? Okay, so I assume if you have issues, don't be afraid to ask, right? Let me know, because we can go through and assist with that. So once you've logged in, you should be then seeing something that looks like this. This is your dashboard page, okay, when you log in. And your dashboard has a variety of information. We're going to focus on a few parts today, but the parts you're going to see is a menu that shows the different types of projects that you will have access to. Everyone, by default, when you have your account that's created the first time, you'll have what are called your private projects. Those are just the default ones that you get. It's a project, it's a way for organizing your files and your data objects wherever they actually may physically be, right? It can be physically on our main server, but it can also be a project that is connected to data on other remote systems that you have access to. So those are your private projects. You'll have others that maybe say have been shared with you from colleagues. You can go there. Then there's also what are called public projects. So these are, for example, data sets, as you'll see, like the BigBrain, that are made, say, public to all CBRAIN and NeuroHub users. That way you can easily navigate them. And then sometimes, if you want to just see them all in a single view or a single pane of glass view, we have the special All Projects tab. So when you cycle through the tabs, you're going to be able to see the different views. But what we're going to go through as an exercise is say, well, great, most people, if you're like me, you're doing too many things at the same time, and you try and find a way of organizing your activities. So you're not going to want to put everything into the one bucket of space of activities that you're doing. You're going to want to say, well, I'm going to create a project for my various different portfolio of activities. So the first exercise that we're going to go through is actually creating a project. We'll do one specifically for the activities that you're doing on today, okay? So what you're going to do is go to the same view, but you're going to go up to the top where it says Create Project, okay? So if you select a project, then it'll pop up an open window where then you can give some information about the project itself that you're going to be working on. So in my case here, I just called one. You can call it one that's specific to your number. It doesn't have to be matter. Just something that gives it a unique name that's identifiable for you, and you can give it a description, right? So in my case, as I said here, I wanted to label it with something that I knew was with regard to this account, so I call mine HB02 BigBrainProject, okay? And there's different attributes that you can assign to this, but for example, you can also, because might be wanting to share this with other project members that you're going to invite to collaborate. We won't try that on the setup today, but you might, for example, as a data project owner, you say, well, I want to share files, but I'm the maintainer. I'll be the custodian, the curator of that data space. I don't want anybody else to be able to modify that. We give options where you can do that type of activity where you kind of checkbox mark it, say that, okay, people that I invite will be able to access, but they won't be able to, assign files or things like that to that project. You can also do things, they say, okay, when you're in a later state, you want to share things publicly so that all CBRAIN users, again, this is not a default, this is, and that's why we say beware, right? Making a project, publicly shareable. And again, as was indicated here, you can make that designation later on. You don't have to do it at creation time. But when you know that data set might be in a state that where you say you want to share it with people who are elsewhere on the platform, you can do so, okay? So again, for that information, and then you just go create, and then you should get a message that says at the green banner at the top, indicating that the project was successfully created, okay? And what do you notice now? You'll have, in your private projects, you'll not only have your default one, but you're also going to have the second project that you just created in your menu of choices. Okay? So this way, like I said, with the create project part, you can keep your work logically organized, even though the files and the resources that you're pulling in come from different connected parts of the ecosystem. At least you can keep your work organized and keep everything logically structured. Okay? Anybody have an issue or any troubles creating a project or get an error message or anything like that? No? Okay, great. So that's the creating project. So you're going to use that project, though, afterwards as part of the end result of a pipeline. You're going to want to run a pipeline afterwards, and you say, well, because I'm working on the BigBrain data set, I want to deposit my data there. So keep track of at least the name. You don't have to remember the exact name because you'll see it in a drop-down menu later as a destination choice. For example, when you want to say, please put my created output data into a certain project, that's one of the projects you can use, the one that you created. Okay? So that's the one there. So now, again, you can see all your projects. So anytime you're working with the menu and you want to go back and see your projects list, all that is available by looking at the projects tab at the very top. You just click on that and you'll always bring yourself back to this entry point here. There's a variety of other ones which we won't really go through and touch on, but this is, I would say, the main one that'll bring you back to your projects list and bring you back particularly looking at your prior projects. But what we're going to do now, though, is say, okay, well, this is supposed to be a tutorial about working with the BigBrain data. You want to, how do you find what BigBrain data is there, or how do you find generally what data is available on the platform, okay? So that's where you're going to see, we're going to make use of these different menus, right? So right now you have just the private project ones. You're going to go through, you can say, well, there's two options. One, I want to just search by name. I assume something that might be called BigBrain would be searchable in there. So we're going to start, rather than getting through a long list of every data set that's available publicly within the CBRAIN, we're just going to do a quick search. So you'll see a menu bar where you can search by name. So just put in BigBrain in there and just hit return and see what you come back up with. You should get something that, it won't be exactly this number because it depends on how you named your project, because each individual user's view will be a little different, right, depending on the data sets. But if you search for BigBrain, when I did it, I came up, and what you'll see here on the left, when you do type in a search, you'll see an active list of filters. So what you're doing by creating this search field and filling this out is you're actually applying some filters to the data space or the searches that you're running. And it'll identify to you what you've actually then applied as a filter. So in my case, I typed in BigBrain, it's done that, and it marks it as a filter. And if anytime you want to get rid of the filter and just go back to a plain, flat field view of everything, you just clear the filters, and then that'll remove that. Or if you have multiple filters, you can also just click the little X next to the filter name, and that'll remove that from your view, okay? So you've done the filtering, you say, well, now, it's in my case, at that time, and I find that there was 13 projects with the name or associated with BigBrain. And you say, okay, well, what's there? So again, looking at that filtered view, this is where we're going to start looking at the different menus, particularly because we know the data set here is shared publicly. So you're going to go to the Public Projects tab, specifically within your view. If you click on that, then you're going to get a view of all the data sets that correspond to that filter selection. Remember, we've done the BigBrain view, and then you'll see the public projects that correspond and have those names associated with the data sets. So you should see this view of all, in this case, there's 11 of these particular data sets. They're under the Canadian Open Neuroscience platform, but these are the ones for the BigBrain data set. Okay, so you should be able to see all those in your list. So try and go through and just to get familiar with the navigation process of working between your public data set space and then the public ones. Does everybody see 11? Okay, good. So what you can say, okay, well, these are, and this is where you have to have some understanding, particularly when you're looking at, say, the data types that are there on the platforms. And usually these different projects provide some detailed information, but particularly if you go through and, the source is always providing the most details. So if you go to the BigBrainProject's website, they'll give you all the details of what types of data is there. These, of course, have been all then organized accordingly depending on the different types, whether it's segmented, layer segmented, and so on. But what we're going to do is work with the raw imaging data as part of the actual exercises you're going to go through today. So, but it's still incumbent upon the end user to understand what is the data you're working with, right? So for things, if you're looking at data sets that are in OpenNeuro, the OpenNeuro page provides details provided by the owner detailing what is the data, what is the nature of it, how it's collected, what are the formats of files. And so the same thing applies for data sets here on the BigBrain side. They provide the definitive information. We just provide a layer on top of accessing that. So if you have to understand what pieces you want to look at. But in this case, like I said, the ones that we're going to be working with are on the COMP-BigBrain part. So you're going to click on that part. So if everyone just clicks on there, but at least the nice part, it tells you generally there's 17 files that are there. Don't worry about the tasks because you always will see 0 because that's owned by, I would say, an administrative view. But then it'll tell you at least the quantity of files there. So if you click on that, you'll then get a listing of what those contents of that data project are, right? So instead of getting a long list on the command line, trying to figure out what's what, you'll get a list here, and then you say, okay, great. This is still providing me a long list. I don't know what's what. The nice thing about this is you can also apply filters depending on a variety of things. So here, in this case, it pages it. So you can control how many you want to view per page. So that way you're getting this long list, but then you can at least don't have to see it all one long scroll. You can also do a search within that. But the nice thing is we also have different categories of information, including the file type. All right. So you can then click on the little magnifying glass. It may not be visible easily here, but it should be on your screen. There's a magnifying glass next to file type. And then you can actually then, in our case, we're going to work with some Mink files today as part of just the exercise. So then you can see that out of these 317 files, about half of those are Mink files, half of those are Nifty files. And then you can actually then, as part of your filtering within the web view, say, I only want to display files of a particular type that I'm interested in working with. So in this case, I'm going to select the Mink files. And if you click on that, even as it is with just the Mink files, you're going to actually get a reduced set, right? Even though it's 150 files, you say, oh, great, that's one view. But I want to ask you to go through, do a further filter. Once you've done that selection of just exclusively Mink files, go through the search by name. And again, just for the purposes of the exercises here, we're going to work with the full 8 underscore file set as well. So that's going to select out another block where you have the 8 color bit spectrum of the files. So if you type those in, you'll now have, then should have something like 2 filters applied. One that you've selected only the Mink files, and the ones that have names that will have full 8 underscore, and then you should have a reduced list then of 13 entries. Okay, so go through and try that. Again, select with the Mink files and the file type, and then the sort by name or search by name. If you get full 8, then you get 13. Is everybody able to see that reduced set? Okay. Okay, so now at least that's giving you a way of understanding of how CBRAIN provides you access to, if you're looking in the case of the UK Biobank, for example, those are organized by participants, and they have like 40,000. So you wouldn't necessarily want to say identify, certain files. Just, if you look at, there's millions of files there, and if you want to select individual ones, this provides an easy way of filtering down and identifying through the interface the file types and particular subsets of files of interest to you. Okay. So what we're going to do now is just to get some familiarity with what you're able to do with individual files directly within the browser. So in this case, I've selected the 200 micron data that's been optically balanced. It gives you information about each of these files. So you can see that the file type, it's the owner of the project, when it was actually created. It gives you information about the size and the project that is part of. Now, just for the purpose, because I don't know how quickly the network is going to react to everyone here in the room doing it, you can see because this is like around a 78 megabyte file, it takes a little bit of time. When I tested it here, at least elsewhere in the university area, let's everyone say maybe pick something that's a little bit smaller. If you pick the full 8 400 micron optically balanced file, that's 10 megabytes, so it should load a little quicker. So this is going to be then loading into your browser the actual file, so you can then visualize it. Now, I have here a checkbox. You don't have to apply the checkbox at this stage. All you have to do is click on the name of the file. So I recommend something like the full 8 400 micron optically balanced Mink file. It's a little bit smaller, so it should load a little quicker because it has to come from the central server to your browser. And this is part of the challenge of when, here's a plug for the talk I'm giving tomorrow. It's bringing the data from the server in Montreal to here to your browser. So you have to transport that. We say, okay, 10 megabytes isn't very much, but if you're on a slow network or a slow Wi-Fi connection, it still adds up, right? Tomorrow, what you'll see is, you can actually bring your compute to the data. But in this case, we're just doing a quick visualization. But in my case, I just did the 200 micron one. So if you click on the file name itself, you'll see a set of information. Okay, it'll give you information that's more detailed about the file. So again, this will become particularly useful when you're creating your own data, particularly when you're looking at outputs of tasks. You get specification not only the file name, its size, when it was created, as I showed in the main menu before, but then you also have directly within that view on the same page, a content viewer. In this case, it's going to provide a volume viewer, and then you'll see the view layout will be a little different on your page. We've tweaked it a little bit since I've made the slide here, but you'll see the 3 different views. You can also, in your case, select the number of pixels, so the size of the image. You can control between the default 256, 512, or 1024. So if you want to get, really the best resolution for what was created for the image. And you can also change things like the color map. And then anytime you move your cursor through an image, you'll get the position within that image. So this is using what's called the Brain browser component that was developed as part of CBRAIN years ago. And we still are maintaining as part of the environment. So you have the nice piece of working with the image. You can actually then visually inspect the file directly before doing anything that you want to analyze it with, just to get a feel for that, okay? Is anyone having any difficulties, or did it load okay for you, the 10 megabyte file? Okay, great. The 78 one takes a little bit longer. So that's the volume viewer part there, but you can also get more specific information. We also have, if you do the drop-down menu, there's more header information. So if you want to see the header information that's in the file, you can select it. And then we also have a Mink viewer, which is separate, that'll open up another browser window that'll run directly. It'll give you a little bit more fine-grained control for viewing the Mink file. But this is one that's directly within the browser. We're doing some extensions now. So for example, we have some projects that don't have the nifty output yet. They were working directly on DICOM files. So we have a DICOM viewer that is in its prototype stage right now so that people can then work directly on the DICOM files. Okay. So even if you arrow back, you should get back to the same view in this case. So what thing you'll notice is that you're, again, having this list of 13 different Mink files. And then you'll see that at any time, one thing that you'll get familiar with is that at the top, you'll see the CBRAIN name, and then you'll see C1P-BigBrain. So remember, this is the project name that you were working in, right? So this is the project that is assigned with these particular files inside. And remember, you've applied these filter points, the Mink file and the full 8_. What we're going to do now is to actually do some pieces where we're going to actually run a processing task using the BigBrain Warp tool, okay, to analyze that particular image, right? So this is where now the checkmark selection will come in handy. So it's okay to run the 200 micron one in this one because it's going to be running locally on a server near McGill, so very close to the data. One thing that you'll see in the talk we're giving tomorrow is that compute server can be in a variety of locations. Not everything is centralized where CBRAIN's orchestration is done. You can have compute resources anywhere around the world that are connected. But in this case, we're going to run it on one of our servers just to be fast. So if you do a check mark box beside the data of interest, so if you don't have to pick that one if you want, but any of the ones here, if you want, put a check mark beside it. And then you're going to do, I'm just skipping over the parts that I highlighted about the one that you select. You're going to select launch at the top left. Okay, so that's going to then bring you to the menu where you then have your tool control. But first, you have to select the tool you want to run on it. So again, there's a variety of tools that will pop up in your menu. You won't see the BigBrain one populated there at first, but that again is the search box where you can type in the BigBrain. That just because of the name of the tool we're going to run here. But you can see we have all the different types categorized. We have different flags that we've categorized each tool. So even if you're not exactly sure of which tool you want, but you know the general type of processing that you want to run on the input data file, you can select it through the checkbox mechanism, and then it'll present on the right-hand side which tools have been categorized based upon that type of analysis. So that way you always don't have to look at the master list of 160 different tools. If you just want to run some form of structural MRI analysis on a file, you can then pick that directly from the type list. Okay? In this case, we're going to start with BigBrain. So if you type that in, and that should then, once you put it in, should autocomplete and present to you the BigBrain tool set information. So it gives you an identifier showing what tags of processing type of tool it is, links to the website. So again, we're not the definitive source of information regarding the tool. So you always should have a good understanding of what that tool is intending to do. That being said, we do provide some help menus that link and take information from the tool source to help guide you along to provide those some additional information. Okay. So here in the list, you're going to see, again, now you have to make a choice between where you want it to run and which version of the software. So this is the nice thing. Here you're going to see just one version list, but then because we have so many tools, if you're going to be running one version today, a year from now, there's probably even now, if I think about it, I think they have a more recent version than this. You want to be able to run different versions of the tool at different times, so you can run comparisons. Oops. Because my screen blanked, probably, yeah. So the nice thing about the containerized piece is everything's labeled, everything's tagged, it's all taken from a common repository, so everything version-wise is there. So then you're going to select not only BigBrain, but then you're going to pick the version. So in this case, select August 2022, and then you'll be able to get that version there. So the nice thing is these tools, we don't just throw versions away, we keep them there for backward purposes, so people can go back, because we know studies get run. People want to reproduce and rerun an analysis with a newer version and compare the output results. Again, all this information is recorded in the database. Okay, so you're going to click on Launch BigBrain Warp. Now, the part you might notice here, it says last wait time. That gives you a rough idea. It's not I would say, guaranteed execution time, but it tells you roughly, depending on the tool you're running, BigBrain Warp in this scenario that you'll be running is a very short running processing task. So that's why we run it on a server that we ourselves have. Some things, like if you're running FMI prep, for example, it can run 18, 24, 40 hours, right? And those we wouldn't run directly on a single server. Those we would submit to a large-scale HPC resource or a cloud-based resource. And based upon prior history of running those tasks, we give a rough estimate of how long it would take before that task would start to run. Not for its completion, but start to run, because sometimes the HPC systems, of course, are very busy. You get into a queue, everyone, including the platform here, or your account on the platform that is being leveraged, has a certain priority, and therefore that reflects then in the wait time that you have to get access to that resource. So this is just a back-of-the-envelope calculation of how long it should take before your task runs. Okay, so we quick launch BigBrain Warp. Oops. Then you'll get to the two sets of menus. Okay, first one is what's called a task control menu. This is one in CBRAIN that you define, because as I mentioned, CBRAIN is really looking at, think of data spaces across the globe that are connected anywhere, but you can organize those into buckets of projects, and that project can contain data sitting in different multiple locations. But then you're also going to specify, what the parameters of the tool are. But this first part is controlling where do you want physically the data to be stored, the derived output data that you're going to be running, and where do you want to organize it project-wise, okay? So at the top, we'll show you here. So you've selected the version where it's going to be running. And now in my case, and for your case as well, for the purposes today, select it to run on main store if it's not already the default there. Main store is meaning just a default space that we give every account. We give everybody an account of a few gigabytes of space, just so people can deposit data there as the output. So for the purposes of the workshop today, you can just select main store. What I would like you to do, though, and when you're organizing again by project, it might give you your default personal project that you saw, HB09 or 10 or whatever, but switch it to the project that you created, right? Because you're going to keep your work organized into different categories depending on the activity you're working on. So not only select main store, but again, that main store is just the physical hardware that it's going to be stored on, but from an organizational point of view, pick the project of the one that you created at the very beginning, okay? Just to help get familiar with that, be able to designate what goes where and what's physically sitting where and how you want to organize it. And you can give it a description if you want as well, but that can be left blank, okay? So that's the top part of the menu. So that controls how CBRAIN orchestrates the workflow. But now you're going to get to the specifics of the tool parameters themselves, okay? So this is where we go from typing things instead of on the command line, or you're writing bash scripts and you're saying, okay, I want to run with this particular value, or even if you're doing manually by hand, you have to put 2 dashes instead of 1, or you're missing some sort of flag, or you mistype a numeral, or you give an error that's wrong. This is avoided by having this environment where you specify the parameters either through a drop-down menu of choices that we take directly from the tool creator. And then same thing, it indicates all the mandatory ones with the red asterisk here. So for example, you have to specify what input space. In this case, you want to work in ICBM space. You want to specify that the output is the BigBrain sim space. So go through and you can drop down menu select and pick these choices. And the part, just to help keep things, I would say organized for yourself, you give a description of your input. So I'd like to give one just saying, okay, this is my task that I ran as a test of BigBrain Warp. On this particular one in the screenshot, I ran that a few years back, and I said, okay, I gave it a -200 because I knew I was working on the 200 micron file. Okay, that you type in by hand, so you can type in whatever you want. Because this tool itself uses FreeSurfer, we automatically include a FreeSurfer license, but nominally you would have your own FreeSurfer license that you have to bring to the environment. But for the workshop, we provide you the common one. Okay, so specify the input space, the output space, and as I said, the descriptor. And the licenses, like I said, preset. But tell me what you see. What do you see when you click on the menu drop-down for the input volume? When you click the arrow down, in my case, because I put, what did I put the checkbox beside in the menu? In my case, I had the checkbox beside full 8_200 micron optically balanced file. So the one that you picked, if you picked one that was different than this, is pre-populated into this drop-down menu. So if you picked a different file or a specific input file, it's already pre-populated in the choice. So that way, you don't have to remember, okay, I typed full 8_200, or did I type in 100 or 400? It's already in the list for you, based upon the selection you made with the checkbox in the file list that CBRAIN provided, okay? So that's the nice part, it provides you that pre-population of the choices. Okay, and the others you don't have to fill out. So these are the task parameters, and the nice part is, beside each set of the task parameters, or at least for the task parameter menus, there's a help menu that brings up a description that we take from the tool provider itself, kind of like the help menu that they provide for the tool. And so we just replicate for that particular tool version the help menu. So if you want more information about what it means when you're selecting the input space, the output space, and so on, the hemisphere and so on, all those details are included in the help menu. But again, this comes to also making sure that you still have a good understanding of what the tool is doing, because the CBRAIN part is really to just help you organize your workflow. The tool information page through the help and the source documentation from the tool provide really the ultimate set of information about the tool itself. Okay. Is everybody at this point where you're ready to, you've selected your file, you've set your task parameters to go to your project that you created at the beginning, and then you've set the parameters for the BigBrain Warp itself? Okay. So then at the very bottom of that list of task parameters, you're going to see then a Start BigBrain Warp button. Then you're going to click on that. And then you should then see something that indicates in green on a green menu bar that pops up that you're launching a BigBrain Warp task in the background. When we say in the background, it just means you can do other things while the task is going through its cycle of activity, of launching, preparing, and then executing, and then completing. Okay? Is there anybody who didn't get a green menu bar? Okay, great. Okay, so this one's very short-lived. It's not going to take more than a few minutes to run. But now what you've noticed, though, is you've gone from where you worked prior. You were working in the Files tab. So remember, again, we had your list of 13 different Ming files based upon your filters. But now you're in the Tasks menu section of CBRAIN. So that means it's going to show you what's things that you've launched processing-wise. So in this case, because it's the first one that is launched, it's told me, okay, I'm launching a task in the background, and there's no records shown underneath. But if you refresh the page, okay, I'm just going to, it may not show right away. It actually, because when you launched it, remember the input data was sitting in CMP BigBrainProject, but you didn't launch it. You're not authorized to actually run a task as that project. You're launching it as your test project that you created. So you want to switch projects, and we have a quick project switcher, it's called. So if you just even click on in that section right above where it says BigBrain CMP, you'll get a drop-down quick project switcher. So it lets you then see the projects that you have access to, and then you want to select the one that corresponded to the project that you already had selected. So in my case, I was running it in this, and when I launched it, I actually didn't switch it to my created project. I had left it with my default. So, but in your case, you're going to want to switch to the project that you created. Okay, and then you're going to see then the view that corresponds to your project. So you should then see the CBRAIN name, the name of the project you created, and then the tasks. So that kind of gives you the task view of that project. And then from that, you should see underneath a list of tasks that are associated with that. Okay, so I'll give you a second to go through that. So if you have trouble with the tasks, or the project switcher, let me know. But if you just go up there, switch it, select the one that you created, and then you should see a task list view. In my case, I have 2 here because I had launched 2 at the same time. But in your case, you should at least have 1 in this with a menu of information here. Now, if you're running, you can watch the full life cycle. This one's a very short running task. It's not, it might even be finished by now, by the time I'm saying this. So the nice part is the task is launched in background, my view. I had it because I had various other ones I was running. I had put a filter there, but I just wanted to see all the BigBrain warps I had. So the nice thing is that you can actually watch the status. So when you're going through, as I said, running FMI prep, for example, it's going to take hours. You don't know if it's even going to start on the queuing system yet of the cluster. You want to look at the particular current status column here, right? This will show you the status of the particular task. So in this case, I had 3 prior completed ones. The first thing when you submitted it as you did, you'll see it as a new task, but then CBRAIN does regular polling and checking in the background for you. So you can actually then watch, and you do a refresh of the page, and then later on you'll see that that status will change. So when we know it's actually running and doing computational work on the system, it'll be running and marked as on CPU. Okay, then you can refresh later. It'll go from on CPU, to completed. So in my case, you'll then get a menu, green menu bar at the top, indicating to you that the task that you had launched was completed successfully, or sometimes, depending on the data itself, has maybe there's some errors in the data, or there's some part of the data space in that file that causes issues with the tool. Sometimes you can get a failure as well, right? Or for example, might be a power outage at the compute resource where it was running. It might have an issue and then it would return fail. But you can always go back and diagnose and look at the logs for all these tasks, okay? So in this case, you're able to see that full life cycle of going from submitted to waiting in the queue, running on the system, and then completed through. Okay, so in this case, this was a completed one, and I got a notification at the top that was completed. Now, the next thing we want to do is just say, okay, well, great, it ran. What do I do? I want to see the output. I want to see the generated information that was created as part of that tool executing on the system. So that's when you go through into the bottom leftmost column, then you'll click on the actual link there under the task type. So that will bring you directly to the output that was created. Okay, so if you click on, in this case, you'll have a BigBrain warp name. Then if you just click on it though, that'll bring you to the page where you can get details about the output that was generated for that particular task, okay? So in this case, it gives you some task information. It'll tell you, okay, that the task was, of course, completed. I might have run it only 1 time, but it also tells me what project I ran it in and stored the output in. In your case, it should be stored with the project name that you selected, which would be the one you created. So at least that we know how it's organized. And it tells you also the size of the output, right? So sometimes you're saying, okay, well, how much space am I using? You, in the end, want to share it or download it to your local system for further offline analysis. You at least want to know what the data is you're dealing with, okay? I won't go through the other elements, but the nice thing is that further down below, you'll see, whoops, I went a little too fast. You'll see a summary of the parameters. So anything that you, instead of normally typing on the command line, if you went the command line route, everything you selected from the menu is visible as a summary of the parameters that you selected for that execution. So when you specified that ICBM is the input space, it's written there and listed there. The output space value, again, written and listed there. The descriptor that you gave it. And also it provides links not only to then just the parameters, but also a direct link that you can then navigate back to the input file that you ran as part of this input task, but also where the directory of outputs are located. So that way you see the full relationship between the input file that you ran on, the parameters that you ran on it, including the tool, and then the output. So all this information and this relationship between those pieces is stored there. You don't have to worry about writing it in a logbook or storing it in a text file, trying to parse it later on. It's all there and stored in CBRAIN for you, okay? Then you can also then go into more details. So say, of course, this goes into now understanding how your tool works, right? So if you're saying, you want to understand what was run, if there were any error messages generated or any warnings, you see the full set of processing log generated by the tool, not only by the tool, but also say by what CBRAIN did in terms of its process of handling things, submitting job to the cluster, process of being set up and saving. So this is more, I would say, the processing log from the CBRAIN point of view. But then you also get access to things like the standard error and standard out from the tool itself. So again, you're not storing these files separately, then trying to find and navigate them. You see them all directly related and stored there in front of you. So if you want, again, like I said, look at the standard error, all the values, these are things that are generated by the tool itself. And the same thing with error. If there's any messages you need to analyze, diagnose, to debug something, this is all accessible to you, okay? So this is, I would say, the power, particularly of keeping that relationship of information together, okay? Now we're going to go through, so in the menu choices, say, well, I want to look at the output that was created, okay? We'll ignore for now the scientific, I would say, interpretation of that, but just to show you, then you can then browse, if you click on the output files that were created, so in my case, it was the particular contents, it'll bring you to the next page that directly shows you the actual created output, and it gives you details of that. So again, the size of the files, where it's stored, which project, and then you can actually see directly the content of the actual produced output. Now in this case, the implementation that we had was including more of a direct copy of the input, but other tools that are a little bit more efficient the way we implemented them. So you'll see the output Minc file. So this generates another Minc file. Again, look at the tool documentation to get the interpretability of what this means scientifically. But the nice piece within CBRAIN is, okay, great. These are stored at what's called as a file collection. So it keeps it as a grouping, all those outputs together because you produced it as an output of a tool. It keeps it all organized in what we call a collection. But if you want to extract and just work with individual files, you can then put a checkbox beside one of these and say, I want to just work with the individual file that was created. You checkbox it. You can run extract. But even without doing that, you can just click on the file itself, right? So in this case, I want to look at this output file, this 8.7 megabyte created file that was generated by BigBrain Warp. If I click on it, I can either download it through the DL button here, or I can actually directly view it within, again, the browser. So again, this is all being viewed directly within CBRAIN in your browser. You're not downloading it to your local system to then try and view locally and manage all that. So you can navigate through the created output as well, okay? And again, the view that you'll have right now is a little different than this one because we can right now have, I would say, better, you can toggle which view you want as well as the resolution of the view. Okay, so that's the output piece, right? So you've gone through that. So now you say, great, Bryan, I've run one task. I'm not going to be running one individual task on one input file each and every time. I have hundreds of files. I don't want to do this 100 times, right? So I think we have enough time for it today because I think lunch is at 12:30. So what we're going to do now is do an extension of this. We're going to say, well, I want to run on many files at the same time, okay? We're not going to do hundreds, right, for the purposes of what we're trying to analyze. We want something that's a little bit more manageable for the exercise today. So if you go back, now this is one-step exercise for you. I jumped a little bit ahead, but if you go back to the COMP BigBrain project, okay? If you could go back, find that project data, but then I want you to apply 2 filters, okay, just to get a subset of the data. One could be you want to select all the Minc files, again, because we're going to run the BigBrain Warp on input Minc files. But then apply another filter here. In this filter, in this case, I selected block. I just typed in the search by name, and this is something you should get familiar with. Again, you need to know the data, so I won't go into the details of what that particular block of representation means. But in this case, I typed in block 40-000. So that's going to select a subset of the input Ming files meeting this particular set of criteria on the filtering. And you should then get 9 input Ming files that we're going to work with. Okay, so go through and try and create that filter. So go back to the BigBrain dataset in CONP, select Ming files, and apply this filter through the search box. So as people have been able to get that filter applied, again, going back to the trick was, part of it's not necessarily just going through the quick project switcher, but you can also then you should be going back to your projects page. You then type in the search menu for BigBrain. You'll get then to the data set, and then you can go inside and identify only Ming files, and then apply the next filter of block 40-000. So now with that particular filter, right, we have this set of 9 files, right? These are all Ming files. They're all part of the project. These are input files. So now you say, we're going to do the exact same thing, but we don't want to have to do this 9 different times, what we did in the prior exercise, right? You want to do this once. But you want to do this in a way that's, again, is reproducible for you later on. So what you're going to do, so you can, in this case, because you have applied this, created this filter, you're going to go through and you can do a checkbox just to put the top one at the list. When you fill out the one that's in the blue menu, top of the menu bar, it'll pre-populate the checks across all of them, okay? So that means I'm selecting, I want to run my task on all these input files in one shot, okay? But you also want to keep record of this, right? So by selecting with the checkbox, okay, everything gets highlighted there. But then we have a way of creating a logical representation of these files where it's called, everyone works with CSV files when you're working on spreadsheets and so on, and that you're going to import into things. We have just a modification that I call the CBRAIN CSV. So with everything checkboxed, then you're going to go on the top right, you're going to see a More menu, okay? And then from there, here's something we call a file list. So in the end, you're going to want to have a record of which files you read as input to this next processing task, right? So you're going to create what's called a CBRAIN file list. So with everything checked, go over to the More column, and then you're going to select Create a File List, okay? It'll give you an option. It'll create the file list for you. You don't have to specify the name, okay? But when you look at the file list itself, logically what it does contain is essentially a set of internal ID numbers that CBRAIN uses to associate the names of the files that you selected. In this case, I had the 9 files here, right? They're internal IDs, which you don't have to worry about keeping track of. What type of file they are, what project they're from. So that information is then kept all together in a file. So when you create that file, it'll put that file, and it gives you a choice, if I remember correctly, of where you want that file to be put, that CBRAIN file list. And you could put that in, for example, into the project you created, or if you want, you can put it into your own personal private project. It doesn't really matter where you put it. But it'll create something called a file list, and it gives us just a numerical tag. You don't have to worry about, it's just the way we have, everything that goes into CBRAIN is always given a unique identifier, so there's no conflict in the names and so on. So that'll be a CBRAIN list of files that you created based upon your selection. So that way, if you want to know what your filter produced as a selection, that entire list is maintained. So you don't have to remember, it's okay, what was in this input? You know what was there, okay? So great. So now what you're going to work with, instead of selecting all 9 of those objects and saying, I want to run the task and doing that 9 different times, CBRAIN has the way, because it's using containers and so on, what we do as a workflow is that we say, well, I don't want to just run on one file. I want to run it on all the files that are contained in this file list, okay? Therefore, what I'm going to do and select as the input is the file list itself. So you put a check mark box beside the file list in the menu that you have. You can ignore, in my case, here, this was from a prior version where we had to separately provide the free server license. But the only one file that you need is put a check mark beside the file list that you created, okay? So you should have then something, the checkbox, you'll say one file is currently selected, and then you're going to select launch, right? Remember, there's the launch menu button just at the top here, right? So you're going to click on launch. And you'll do the exact same thing that you did before, okay? You get the tool menu option. You're going to type in BigBrain or just the beginnings of it. You'll get to the same process that you experienced before, BigBrain Warp. You select the server and the version, right? In this case, you only have one choice. I think, sorry, I might have missed that earlier. It's converter 2. That's just the name of our server that we have for that particular tool installation. So you type in the name of the tool, launch BigBrain Warp. Remember, the key thing is now you're not doing this 9 different times manually for each file. You're telling it to take as input the file list that you've generated, okay? So now you're going to get to the exact same menu of options where you're doing your task control, right? You want to tell it to store it in main store, right? That's just the physical server that we have, right? But then you can specify, again, the project that you created at the very beginning, the very first exercise. And you're going to do that, but then you're going to do the exact same thing, but remember, set input space as ICBM, output space as the BigBrain sim. But now in the descriptor, you know, again, these are more the more human readable things that you're going to type into here. In my case, I'm saying, okay, I ran BigBrain Warp, and I ran it on a certain date just to help myself, even though I know the date's recorded or in CBRAIN. But I just made just a note that I ran it on the CBRAIN CSV file or the file list, right? So just I had a description of that. But the differentiator now is, remember what did we see before when we selected the input volume, when we did a single file, right? You saw the name of that single file. Now in the drop-down menu, you should see the name of the file list you created. So just to bring us recap where everything is, so you're using the same settings that you did before for the task control, right? Meaning the physical storage is on our main server for now. The project is the one you created at the very, very beginning first exercise. You're specifying the input parameters now for the BigBrain Warp tool, to the same values that you ran previously, but instead this time it's going to be applied to every single one of the 9 input files that you created as part of this file list, right? So here you're doing it one time on a file list, and that will run. If you think it's going to run, you have 9 files in your file list, it's going to run 9 separate tasks. So then you go start BigBrain Warp. And then you'll see at the top, when you launch it, instead of saying just launching 1, it'll tell you it's launching 9 BigBrain Warp tasks in the background for my particular filter. Okay, so go ahead and fill those out in terms of the task parameters, the tool parameters. And if you have any questions or if there's any issues, let me know. But then you should be then having it launching 9. Now these will take a little longer, right? Because you're not just running 1, you're running 9. And then there's a few of you here in the room. So then when you refresh the page, you'll get a list. You should see the ones that you ran before as completed. And if you, then you also will see ones with a plus. The plus means then you're going to have multiple concurrently running. So in my case, I have 9 new tasks in this particular time of view that I made. They're getting prepared to run. Okay, so let's everyone just submit the tasks for and let's see where we're at. Has anyone else seen the issue where you didn't see the plus as well? So for example, if I go back to the slides, I just want to double check if anyone else has had the same issue where, let me just bring it up. Oops. So in this case, when I submitted with the 9 before, it should provide you with the difference being, remember when you ran it with the singles, the task type would just be the name. But now because there is the 9 in together, there should be a plus symbol. The plus means that there's more than 1. And you should see something that says a 9 on CPU or 9 completed. And then with that, if you click on even on the plus, you can actually then get an extraction that shows of each individual one. I know that your group here, you didn't see the plus, but were the other people not seeing the plus, or the plus was there? No plus? No plus? No plus. Okay, I'll have to double check why that was the case, because I ran it before. So the benefit, at least, of this, in theory, obviously, live experiences sometimes are a little different when we have a non-regular user environment, because we created one for the workshop here. The benefit of this is that when you launched it 9 times, is that you would then have 9 individual tasks, and then you can see the status of each one individually, and then you can actually then drill down and to see the output. So just as like you did for the individual one file that you ran, you get, once it's completed, you'll get a message at the top. Again, I'll double check why the 9 didn't process as the CBRAIN CSV, why it was doing that. But then you can actually then go and look at the individual outputs. You see them all completed. And then you have the individual collection. So these are then the process outputs that you would see. So instead of doing it 9 separate times, you get 9 separate output boxes here. Again, apologies for this not working at the moment. I think it's related specifically to the fact that we have specific accounts that we created for the workshop here. But in this case, like I said, when I ran it here, individual outputs, so then I can navigate directly into each of those outputs for those 9 files. So you're seeing, rather than doing n times the work, you're doing 1 time, and you have it doing the actual computational exercise with you doing the same set of steps that it did for 1. So it makes it much easier to run. And again, just like everything before, it keeps track of all the outputs, the relationship between the input and the output, okay? In the actual exercises, like I said, that are linked there in the notes off the agenda, we have additional ones that I've had as a last exercise. If you want to then navigate the actual contents, you can still do this even if though the last exercise didn't go according to plan. You can navigate the next exercise, number 6, to give you some examples of, for example, how to download files. So individual ones, you can say select to do a download through the web browser. Now this doesn't work, by design, it doesn't work. We don't want people downloading gigabytes and gigabytes of data through the web browser for various reasons, including it's going to be extremely slow for you just from collecting through the browser. So through that, you can do individual files up to a small size through the browser, but we also provide an SFTP interface, and depending on the nature of the data that you're connecting to, it could be something like S3, but in our case, an SFTP interface. So it doesn't really matter if you're familiar with the command line to use SFTP, you can use that. Or if you have any more, I would say, graphical-based tools, like in my case, I like using CyberDeck. I connect with the parameters that are listed at the end of the slide deck. I can then browse, connect, and see what's actually there on the CBRAIN side, and then I can do bulk downloads. I can say, I want to download the following files, select download, again, using the tool of my choice because we're using the same standard protocol, okay? And then everything I can watch and monitor, and everything goes to my local system for those cases where I want to download the produced outputs. Again, we try not to be specific. We just say, okay, we select the protocol, and then any tool that you're of choice, whether you're running on Windows, you can use other software tools to interface with it for the bulk downloads, Mac, whatever. You can use whatever method you want because it's all speaking the same underlying protocol, okay? So you can use that as an optional exercise. The accounts will be around for a little bit till probably the end of the week. We'll keep them a bit. We'll investigate to see exactly why those 9 didn't launch. They should have there, because when I looked quickly, it took the CBRAIN CSV file as input, but it didn't spawn the 9. I'll check with some of my colleagues back home. As I said, so this gives information about if you want to practice the downloads. But otherwise, just to wrap things up, since I know we're right at lunchtime, and I don't want to be in between you and your lunch. Certainly would appreciate any thoughts and comments or discussion during the time here this week. If there's any things that you'd like to see how to apply this to your particular work projects and your activities. We have a user guide that's linked off of here. This is off our wiki page that gives you examples about creating an account that you would use beyond the exercises that you've done today. We have step-by-step examples of running through various pipelines, screenshotted so you can see step-by-step exactly what was done to run those pipelines. We have a public page which lists off, you don't need an account for the second one, where it just gives a full listing of all the scientific tools and data sets that are available through the environment. And then, certainly there's going to be questions that come up, right, or any things that you're not sure of, or you want to ask something. We have different ways of reaching us. One, we have a built-in user discussion forum, so you can see what other people have asked before, right? If there's any things that people might have asked about running or downloading things, they've asked those. Obviously, it helps then build that sense of community information sharing. That's through our discussion forum. And then you can also reach us through our ticket system via email, and that puts, like I said, into contact not just with one person, but with the whole team, so then it can be reassigned appropriately depending on if it's something simple, all the way something that's a little bit more nuanced that needs some developer attention to resolve something. So those go all into our ticket management system. So thanks you for your time and your attention. Apologies for that one exercise not working out, but we'll investigate that there. Like I said, all the slides will be available, are available online, and the accounts will work for the week. And I'm happy to, like I said, I'm here till the end of day Wednesday. So if there's anything you want to, like I said, talk about to see how this could apply to your work area, I'm happy to talk more. So thank you.